Hey guys, what's going on? It's Chavez here. I know that I said I was going to be uploading this activity in the morning, and I did expect to upload it in the morning, but I got caught up with errands and I just got back a little while ago. And as you can see in the bottom right hand corner, it's 12:42. So I didn't do a good job of staying on. Well, okay, I stayed on task. I just didn't do a good job of. I didn't know it was going to take that long, and I guess when you do what, you know what? Let's just get started. So you being a super awesome engineer, if the Texas hires you to build a portion of a roller coaster track in the shape of a sinusoid, check out the picture to the right. You have been hired to calculate the length of the horizontal and vertical support beams. Okay, that's cool. The high and low points of the track are separated by 50 meters horizontally and 30 meters vertically, and you can see that separation with the little arrows here. So let me see if I can take advantage. You can see that 50 there and the 30 there. The low point is 3 meters below the ground, and let y be the distance in meters. Why did I write in meters, yo? I'm sorry, guys. I hope I didn't annoy anyone there. A point on the track is above the ground. Let x be the horizontal distance in meters. A point is on the track from the high point. Find a particular equation for y as a function of x. Okay, so usually with these guys, we write y equals a cosine b x minus c, close, plus d. But I can already see that I have a peak right on the y-axis. So your c is going to be 0 because if we use cosine, there is no shift. So 0 because we're using cosine. Because we are, because we're using cosine. And the peak's right on the y-axis. I think the next might be easiest to find is the amplitude. They tell us a little different than previous problems. The difference between the high point and the low point is 30. So half of that has to be the amplitude. So the amplitude is 15. And there's other ways to get the amplitude. That's not the only way. Now, knowing that knowing that the amplitude is 15, they tell us that I have a point down here at -3 because it's 3 meters below the ground. So -3 plus 15, I believe that's 12. So that's going to be your midline or sinusoidal axis. You don't have to do it that route, guys. There's other ways to do it. Let's see, -3, the highest point is the difference between the low and the high is 30. The highest point is at 27 meters. You could have always done 27 plus a -3, which is 24, and then that divided by 2 is 12. And then for the B, the difference between the high and the low, this is 50% of a cycle. So because that's 50% of a cycle, that means the period, that's half the period. So the whole period must be 100 meters. So the B is 2 pi divided by 100, which is pi divided by 50. So there it is, guys. I have everything I need. So here's the equation. Y equals 15 cosine, and let me do a better job of writing cosine. Cosine of pi over 50. You don't have to put a parenthesis if there's no shift. So I'm just going to write x like that, and then plus 12. I hope that made sense. I can't really see you guys or hear you guys, so I can't tell if you guys are saying, yeah, that's cool, or no, that's not cool. The next, it says, letter B says, the vertical support beams are spaced 2 meters apart, starting at the high point and ending just before the track goes below the ground. Make a table of values of the length of the beams. Okay, so X is like my position of the beam. They tell me that it's 2 meters apart, and then this is going to be the vertical height of the beam. Now I know the very first one, the very first beam that I have here, and by the way, this is not drawn to scale. The very first beam is this one in red, and that one is how long? I'm waiting, guys. No, I'm kidding, guys. I can't hear you guys. If you said an answer of 27 back there behind your computer there, good job for you. It's 27 meters, and you don't have to put the M there if you put right here M for meters. So I know the first one is 27 meters, and then you can find the second one by plugging in a 2 into your original equation and the 4 into the original equation, and then go all the way until you get to here. And no, this is not drawn to scale, so you can't just count and see, oh, okay, that's how many I'm going to do. So let's find out where that is. I'm going to use Desmos. So let me go ahead and, well, there's no reason to switch screens because we're not in Zoom, right? So I can just go right into it. So let's see. I don't know why I did that, guys. I was trying to look for the search. and boom. And then here it is. I'm going to go to Desmos, I push graphing calculator, and then I just write my equation in there. So I'm going to need the assistance of this guy, and I'm put f of x equals 15, and then it was a cosine, and then it was pi over 50, and then I had an x on there. Close this guy, and then put plus 12. And of course I don't see anything. I have to mess around with the settings, so I click on the wrench here, and let's see, we're gonna go from -5 to 60, and let's see, we're gonna go from -5 again to, the roller coaster is only 27 meters high, so let's go to 35. Wow, what happened there? I messed around my settings. I don't like it. -5 to 60. Put 607. And -5 to 32. So there it is, guys. Here's the top of my roller coaster. That should be at 27. And way down here, so here's where you're going to have the last. So you're not going to have a beam at 40 because 40 would have been, 40 you're already underground. So the last one's going to be at 38. So there's an easier way than just going like, okay, what is it at 2? What is it at 4? What is it at 6? So plug it in. And that's by making a table, guys. So you can just go to the second table, and there it is. If it's a TI-84, if it's an Inspire, you do the same thing. Go through the menu list and find a table. On Desmos, you just click on table here, and then I'm going to remove that X there. I'm going to remove that Y one because we called it f of X, and I'll just type in f of X. And again, we got to remove that little gray box there. So boom. All right, and now let's see. I go 0, and there it is, 27. I'm gonna go 2, and hopefully Desmos is smart enough to know that I'm going by evens, and it is. So you're gonna do all those. You don't have to write them all in there, and there it is. You're gonna go all the way to 38. So the way you do it, you're gonna go 0 2 4, 0 2 4. Give me these values, guys, and then put dot dot dot. 3 dots in a row means that you have a sequence and that you're continuing with that sequence. And there's an obvious pattern. As you can see, I'm only going by even numbers. So 0 2 4 dot dot dot, continue the sequence, and then give me the last 3 there. So let's see, 38, 36, 34. So 34, 36, 38. And I'll give you the one at 38. It's a pretty small one. 38 is 1.065. At least 3 digits, guys. 1.065. 1.065. You guys fill this in, please. Don't leave it like that. And there it is. Those are my tables. If you want to write them all, go right ahead. If you're doing this digitally, you can maybe print screen of Desmos and then insert the table in here. Whichever is easier for you guys. Continuing. Well, I guess pause it if you're still doing letter B, guys, and then you can start it again a little bit. Continuing. On letter C, it says the horizontal beams are spaced 2 meters apart, starting at ground level. So I need to fix that spelling error there, and ending just below the high point. Make a table of values of the horizontal beam length. Okay, so now we're doing this. So let me go ahead and write my equation again. Y equals 15 cosine pi over 50 x plus 12. So now we're doing this, guys. When I plug in a 0 in here, I want to get that x value. What is x? And then when I plug in a 2, when I plug in a 4, I want to find all those values. So essentially, it's like the inverse, right? So here's my table. I'm going to put y there, and I'm going to write horizontal beam length because the other one was vertical height or vertical beam length. I'm going to write horizontal beam length. And now I know the first one. The first one, we got it from Desmos. That was that 0 that we got, right? So hopefully we're understanding what we're doing. The first one was this distance. Well, because remember, I'm starting right on the y-axis. So it's talking about this beam right here along the ground. So this beam along the ground is 39.758 meters long. 39.758. And I guess I can put the word M up here. And there it is. And then the next one is going to be some number. And I could write y equals 2 and then find the intersection. And then y equals 4 and then find that intersection. But we're not. So what we're going to do, guys, we're going to have to solve for x on this so we can have an equation. And then we're going to type that equation into Desmos. So let's go ahead and do that. I'm going to do it in blue here. So what I'm doing is I'm going to solve for x. I know that some of you guys in tutoring, I told you guys to switch the x and the y and then solve for y. It's the same thing. Relax. Well, probably if you were in tutoring, you're probably not watching this video, right? So here we go. I'm going to move the 12, so I'm going to write 15, because I like to have what I want to solve on the left-hand side. Pi over 50x equals y minus 12. And then next, I'm going to divide by 15, because we're trying to solve for x here. Divide by 15, divide by 15. So we're going to have cosine pi over 50x equals y minus 12 over 15. And then I'm going to do the inverse of cosine. So I'm going to have pi over 50x equals, and instead of writing plus minus, the reason why I don't write plus minus, guys, is because I only want the positive values of the horizontal beam. So that's why I don't write plus minus. And if you're wondering, like, how come you're not writing plus 2 pi n? Well, this roller coaster is not doing this over and over again. I'm just looking at a section of the roller coaster. So that's why I'm not writing plus 2 pi n. When you multiply by the reciprocal, it would be 100 n, because the 100 is the period. So now I'm going to multiply by the reciprocal. X equals 50 over pi, or cosine of y minus 12 over 15. And there it is, guys. So this will give me all my values depending on what y is. So and as you can see, let's see. I hope that we are smart enough because we're using logic here. So what is the biggest y value that I can have for my horizontal beam length? No, I'm not waiting for an answer, guys, because I can't hear you guys. But think about it. So you're right down here. And so at y equals 0, I got a value of 38 point whatever. And I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, all the way. And can I go all the way to 28? Can I go all the way to 30? No, you're right. Well, I'm assuming you said no back there. No, you're right, because the highest this goes is to 27, guys. So I hope that you can see that you can't go higher than 28. At 28, it would be 0. So I'm going to type in my new equation in here, and I hope that when I get to 28, that it gives me an error. So let me see what I'm going to type in there. I'm going to type this guy. I'm going to call this g of x, and I'm going to write an x because the way Desmos works, it works as x is always independent and y is the dependent one. Like y depends on x. So hopefully that made sense to you guys. So I'm going to write this equation. I'm just going to put an x on the inside because x is always independent. So here we go. 50 over pi arc cosine. All right, I think I can remember that. So let's go to this one right here. I'm going to call that g of x because I'm going to need f of x eventually. G of x. I'm going to put an equal sign. And it was 50 over pi. And it was arc cosine, so functions, arc cosine, boom. And then I'm going to open up another parenthesis, x minus 12, close, divided by, that way, see how the x minus 12 is grouped together, 15. And I'm going to turn off that graph in a little bit, close it. Oh, I don't want to close that guy, close over here. And there it is. And I'm going to turn off that graph because at the moment, it's not really telling me much. I mean, you can get information from it, but all right. And what I want is a table. So I'm going to go to plus. I'm going to put table. And I'm going to erase this x of 1 and call it x. And I'm going to erase y of 1 and call it g of x. G of x. And there it is. And I'm going to start at 0. And there it is, 39.758, just like we predicted. I'm going to put 2, And now Desmos knows that I'm going by evens. And there it is, all those points. And we should be able to go all the way to 26. Now, if I push enter again, I better get undefined at 28. So let's see. And there it is, guys. And we get undefined at 28 because this roller coaster only goes up to 27 meters. So there is no horizontal beam at the 28th Y location. So I hope that makes sense. Give me the first three on a table, 0, 2, 4, and then put dot, dot, dot. And then give me the last three, the 22, 24, and 26. And now's a good time to pause the video if you need to do that, guys. So go ahead and pause it. All right, so here we go. All right, guys, here we go with the last one now. So letter D, it says you must know how much support beam material to order in the most time efficient way. Find the total length of the vertical beams and the total length of the horizontal beams. So what I want to do is I want to add up all these lengths here. And I guess, well, those aren't necessarily Y lanes, 0, 2, 4, dot, 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 and then the last three. I want to add them all up, and well, those are actually your X lanes, right? And I want to add up all of these. And I already have them in Desmos. Excuse me. I already have them in Desmos, so now it's just a way, like, how do I figure out a very fast way of adding them up? So it's using the sigma Greek letter. It stands for sum. This is your sigma. And usually you have a start in the bottom and a stop in the top. And I didn't make a good, it's not supposed to be curved like that. It's supposed to be a straight edge. So what I mean is, if usually they use the letter N, and if I have a 0 here and I have a 2 there, that means that it starts at 0. So 5 times 0 plus 5 times 1 plus 5 times 2, and I stop. And there it is. And it works the same way with equations, guys. So let me see if I can write it better this time. So there is my straight edge. And there it is. It's a lot better looking now. I don't have, usually this starts at 1 or 0, and really I can even have negative numbers, but you don't usually see that. And then there's my stop, and I can write G, instead of G of X, because I wrote an N there, I have to write G of N. And what that means is G of 1 plus G of 2 plus G of 3. That's what it means. So let's go back to Desmos and see if we can figure out how to add. And of course, all this here, guys, was just notes on how to use the sigma symbol and what it means. So hopefully we got some good notes there. All right, guys, let's go ahead and start. So I'm going to go back to Desmos. All right, so let's do the F ones first. So let's just start with adding up these two, F of 0 and F of 2. So I want to add up those two, 27 plus 26. I'm going to go down here. I'm going to go to number 5. And I'm going to type in F of 0 plus F of 2. Now, if you want to continue this pattern, guys, you can. You can go F of 0 plus F of 2 plus F of 4 plus F of 6 all the way until you reach F of 38. And that will give you the total length of beam for, what was that one, horizontal or vertical? For vertical. So see, it's 53.881. Now, Chavez, that's not what they were asking for. I know, guys, but I just want to test out how to use the sigma symbol. I don't want to just plainly give you the answer. I want you guys to learn. So here's my sigma symbol, which stands for sum. And right now I'm adding these two, and I want to know if I can add those two successfully. So I'm going to put F of 0 down here. I'm going to put F of 2 up there. And I'm going to see if writing F of n will give me my right sum that I have there. F of n. And I can already see that it is not. So we got to figure out a pattern. So right now, what's happening here? Well, let's understand what's happening. Right now, we're adding F of 0 plus F of 1 plus F of 2. So we have an extra term in there. We have that F of 1 that we want to delete. So how do we delete that F of 1? Well, I bet you we can put a 1 up here. And now you're probably saying, okay, why are you doing that? Well, now look, it's very close, but it's still not correct. It's not the right answer. Because what it's doing right now is doing F of 0 plus F of 1. And because these numbers are really close to each other, the F of 1 is really close to F of 2. That's why it's giving me a really close number. I don't want F of 1, guys. I want to add F of 2. So we can trick the computer by putting a 2 in here. And now look at that. It's the same number. So what's happening? now that I put a 2 in there, what's happening, look, this is like my first one. The first iteration is going to be f of 0 because it's 2 times 0. Plus, the second iteration is going to be 2 times 1, which is f of 2. See, so now we got it, guys. We got the correct formula. So now, but remember, because we put a 2 in there, we're not going to go all the way to 38. Well, at least in the top, right here. That's what I'm trying to say. That here in the top, I'm not going to put the number 38 because that's going to be 38 times 2. So I got to think of a number that times 2 will give me 38. Does that make sense, guys? If it doesn't make sense, rewind it and play it again, please. We got to think of a number that when I multiply it by 2 will give me 38. And that has to be my last term. So it's not 20 because 20 times 2 is 40. So it's 19. 19 times 2 is 38. So I'm going to make the top one end at 19. And there it is. This is how much vertical beam length you need, guys. So hopefully now that we understand that, I'm going to do the same thing with the g of x, guys. I'm going to go to functions. I'm going to go to sigma, or the sigma notation. I'm going to start at 0. And we'll worry about what number we're going to put here in the top. And I'm going to write g of 2n. Why did we write 2n? Because we want g of 0, g of 2, g of 4, g of 6, g of 8. We don't want all the other intermediate ones, guys. Close it. Now think about it. For g, I don't want it to go past 26. So I want the last iteration to be g of 26. So this is 2 times some number. So 2 times some number gives you 26. What is that number? Yeah, you're right, 13. Well, I mean, I didn't hear you, but I'm assuming you said it. 13 times 2 is 26, so I put 13 in there. So this right here is how much I'm going to have to add up in for the horizontal beam length, guys. So I hope that made sense to you guys. So there it is. The F is a vertical, the G is a horizontal, and I don't see any errors, so I think we are in really good shape right now. So there it is, guys. Go ahead and put those beam lengths down, and then to sum them up, all you got to do is, I guess you can do it in 2 separate ones. You know what? I'm going to leave that as an exploration for you. Just type this down here, and then put plus, and then write this one again. That's it. So just copy paste that, and then put the plus symbol, and then put this one. And it should work. Or if that doesn't work, guys, and you're like saying, man, Chavez didn't do it right, then just take this number and add up that number. It's only 2 numbers in there. That's for figuring out how much total beam material we need. So there it is, guys. I hope you future engineers and future medical doctors and future logistics operators are understanding how much to order, or how to calculate the summation of stuff. Of course, this is not a statistics class. This is not one of those courses where we're teaching you how to sum stuff all the time. But it's good to know. When we get to sequences and series, we might start using these over and over again. But I hope that made sense, guys. So, all right, guys. Hopefully, if this helped you out, give it a thumbs up. If you didn't like it, I guess you can give it a thumbs down. But, it would be cool with a thumbs up. And that's it, guys. I'll talk to you guys later. Bye-bye.